Yeah, now I'm going to talk about scanning techniques, citing characteristics there. We'll talk about the terms scanning and fixation. Those are important in increasing your capability to spot something. Talk about how aircraft motion affects our scanning patterns. Talk a little bit about your visual system, as we're relying on the eyeballs there. Fixation points and scan lines. A term that you will see again, would be my guess, is called scanning range. So you want to be able to define what that is. And we'll talk about some suggested scanning patterns. A little bit about atmospherics and lighting. And then once we've talked about the mechanics, we'll spend some time talking about what are we really looking for. And in the case of a missing airplane, you're not looking for a missing airplane at all. If that airplane crashed, it's very unlikely for it to be intact. What you're looking for is evidence that an airplane was there at one time. Okay, so let's talk about scanning patterns. And we'll start by defining what scanning is. As you can see there, scanning is a process of investigating, examining, or checking by systematic search. We use a combination. They talk about systematic head movement. That's something that whoever put the briefing together picked up, but it's not in the standard CAP references for scanning. And in fact, as you scan, it's a combination of head movement and eye movement. And basically, what you want to do is look at a point, fixate on it for a fraction of a second, and then move your eyes and your head to another point, fixate it, and so forth. What you don't want to be doing is trying to have your eyeballs constantly moving, because the part of your eye that detects as the best visual acuity is the central part of your eye, the fovea, and that part does not respond well to motion. It responds very well and you have good acuity when you stop and look at something. But if your eyes are moving, your acuity drops off. And in fact, when your eyes are moving, your visual acuity is best by the peripheral vision. That picks up movement. And that's why if you notice, if you're concentrating, reading a book or something, and somebody walks into the room and they're behind you and almost out of your view, and they walk by, if they walk by, your eye will pick up that motion there. So one of the things that happens if you're flying along and you're just looking out the window at the open air, your eyes will naturally focus on a point about 30 feet in front of you. And if they're focused on a point 30 feet in front of you, something that is a half mile away is not going to be in focus. And because it's not in focus, you're less likely to be able to perceive it there. So it's real important that when you start scanning, that you pick an object on the ground at the scanning range away from your airplane, about a half mile to a mile, depending on the terrain and the search visibility, and consciously focus your eyes on that point there. Where your peripheral vision, although your peripheral vision acuity is only about a tenth compared to your central vision, where the peripheral vision comes in advantageous is detecting motion, like I talked about, and also that is where you have the best acuity at night. So in low light conditions, your peripheral vision will actually be better than your central vision. In fact, you can see that if it's really dark outside and you look at something and you stare right at it, it's a little pinpoint of light or a dimly lit object. That object may in fact completely disappear from your view. But instead of looking directly at it, if you look offset one way or another, up or down, or left or right, that'll bring it back into view. So here we're talking about a circle that is 10 degrees in diameter there. And a way you can estimate the 10 degrees, if you hold your fist out at arm's length and look at your fist subtends about 10 degrees. And what's kind of interesting, if you're a bigger person, you're going to have a longer arm, and so that fist is going to subtend the same 10 degrees as a smaller person would with a smaller fist there. So they found that's a pretty accurate way to estimate what 10 degrees is. You can use that for a couple of reasons. One is to calibrate your eyes as to how large an area you should be scanning at any given time. And also you can calibrate your eyes as far as how far below the horizon you want to be going out when you scan. Obviously, you don't want to be scanning all the way to the horizon because the horizon may be 5, 6, 10 miles away, and you're not going to see the kind of things we're looking for at that distance there. They do talk about dark adaptation. To really have good night vision, it takes about 30 minutes of non-exposure to bright light. So if you're planning to fly at night and hoping to maybe spot somebody with a strobe that landed in the ocean, then you would want to dark adapt and make sure that you don't expose your eyes to bright light. And if you do have to use some brighter light, a technique you can use is close one eye, use the other eye for that brighter light for whatever task you might be doing. And then when that light goes away, then you can open the other eye. At least you preserve your night vision in one of your two eyes there. Because at night you're using your peripheral vision, which is a much wider angle, it doesn't take as many scans to cover a certain area over the ground. You can cover that same area almost just by looking casually in that area, as opposed to a very focused, well-disciplined method like we would use during daylight. Okay, well, let's talk about a couple of things here. The picture there is depicting an airplane, and it's flying out of the screen at you. That's the direction it's going. So it's flying straight at you. This line here is pure vertical. And then this is your scanning angle. And basically what we're looking for is for this angle here, which is your scanning angle, is usually somewhere between about 10 and 20 degrees below the horizon. So that's where you can use your fist. And basically, if you take your fist out to the horizon and then go 2 fists down, that would be 20 degrees down. That would be as far as you would want to be looking. So you don't want to be wasting your time looking way off to the side of the airplane when in fact you're not going to be able to see anything because of the search visibility. So search visibility, that is going to be the farthest distance that you can expect to spot your target of interest at the altitude that you're flying. And typically we fly 1,000 feet above the ground. And at the fact that you're in a moving airplane. So again, search visibility is the farthest distance that you could expect to see your whatever objective you're looking for at the search altitude you're at in a moving airplane. So what we do is we take our scanning range, and we want our scanning range, this thing here, to be less than our search visibility. There's no point in scanning way out here because you've already determined you can't see anything far away. So our scanning range is going to be either equal to or less than our search visibility. For Civil Air Patrol, kind of a going in value for that is a half mile. And we're talking about nautical miles. A nautical mile is 15% greater than a statute mile. Statute mile, as you know, is 5,280 feet. A nautical mile is 6,000 feet. So typically a half nautical mile would be 3,000 feet. So you're looking between, right underneath the airplane, as low as you can see, and out to 3,000 feet. The half mile, if you do the geometry, that would make this scanning angle here 18 degrees. That's why we say 20 degrees. Let's focus now on the right side of this diagram. And this is a depiction from the airplane looking down. And this would be looking down out of the left rear window of the airplane. So here's the airplane flying along like this. So if you're in that seat and you're moving your head left and right like this, thinking that you are searching directly perpendicular to your flight path, directly outside the left side of the airplane, you're not really doing that. And the reason you're not is in the process of doing this scan and fixating and then moving it and fixating, the airplane has moved. And so instead of looking at these 3 places over the ground, you're actually looking at these 3 places. Because now by the time your eyes get out here, instead of the airplane being there, the airplane is right here. So in order to compensate for that aircraft motion, your scan pattern needs to be diagonally like this, towards the rear of the airplane, from the airplane towards the rear. And whether you start here, which would be your scanning range, right, and move in, or you start at the airplane and move out, really doesn't matter. Either one that will work for you. What that will do, though, is by scanning diagonally, you in fact will be scanning perpendicular to your aircraft's flight path. So another way to think about scanning range, sometimes it's defined, if you took this line as the airplane is coming out of the page at you, it would be forming a line over the ground as it hit the ground, and that would be your track. The scanning range would be another line parallel to the aircraft track at your scanning range distance away. So that's another way to look at that. I think we probably have a picture that better shows that. Important to note here, your scanning range has to always be, by definition, less than your search range. So on a day where it's real foggy and smoky, maybe you can only see this far where my cursor is. So what you would do is, in that case, you would bring your scanning range into that same distance, because you'd be wasting your time looking through a bunch of smoke over here. And instead, we concentrate on this part here. Okay, so we talked about scanning, moving your head, focusing on the ground, not focusing on 30 feet in front of you. Fixating momentarily, not just, you don't want to just have your eyes in constant motion there. And what we're trying to look for is something that's unnatural, something that just doesn't belong, just doesn't seem right. And so after a while, when you're flying over terrain, you'll get a feel for what's normal, what looks normal, what a stream might look like, what the growth of the foliage is, and so forth. So when you see something that's abnormal, that's what's going to key you to investigate further there. And so we've got listed some clues here to think about. And this bullet here, if you're in a forested area, you might see some broken branches on the top of a tree, or top of a tree clipped. You could see a burn spot, that's pretty common, or an area that's discolored, or a gap. You got an area where the foliage is fairly uniform, and then there's one gap somewhere that looks out of place. So basically, you're looking for something that just doesn't look right. That's going to be the key. And again, you're in the case of searching for a airplane, you're not looking for an airplane with a fuselage and two wings and a tail and landing gear. You're looking for parts of an airplane. So again, the key is having a discipline of focus there. We're looking at a coverage of about 10 degrees. The reason this looks funny here is if our airplane is here at the bottom, the farther you go away from the airplane, the bigger the area is that 10-degree circle is going to make on the ground. So you would want to spend more of your time looking farther from the airplane and less of your time looking closer, because if you're closer to the airplane, you're more likely to see something than you are farther. When it's farther away, it's smaller, so it's going to take more time to do that there. Within this 10 degrees, you might fixate here once, fixate there, fixate, something like that as you come in. Let me summarize that by saying that the key to effective scanning is being methodical. So if you're just out there and kind of lollygagging around and sightseeing and checking out the waterfalls and looking for whales, you're not going to be very effective. It's a very disciplined thing. It's tiring, so you don't want to go more than about 15 or 20 minutes without taking a break. So that's important as well. When you are to the point where you feel like you need a break, tell your mission pilot, and you'll knock off the search, climb up to a higher altitude. Everybody can chill out, drink some water. You can work on your mission log, keep that up to date. And then once you're rested, after about 5 minutes or so, drop back down and continue the search. So I'm going to present one technique that some people have found to be effective It's not the only way. It's just a kind of a starting point. And what you need to do on your training flights is try different methods and see what works best for you. But here's an example of somebody scanning from the left rear window of the airplane. So he's back here in the airplane, looking out, and you can see the diagonal scan pattern where he goes like this, and then he comes back, goes like this, comes back like this, and then repeats the whole thing over there. They talk on these slides that need to be updated a little bit. They talk about searching at 500 feet AGL. And in CAP, we do not search any lower than 1,000 feet AGL. That's our minimum altitude for searching. We are authorized to drop down to as low as 500 feet if we want to confirm the sighting of some object, get a better picture, a better view of it. Or in the case of aerial photography, if we need to drop down that low to get a good picture, we can do that. But other than those two momentary dips below 1,000 feet, we're always at 1,000 feet AGL, above ground level. So at 1,000 feet, like I said, kind of the going in spacing for your scanning range, and here's a better example of scanning range, is half nautical mile. So here's the aircraft track. I could, it's the way the airplane's going over the ground, that's the track. And the scanning range it also is an imaginary line that's parallel to your track that is offset by a distance also called the scanning range. I wouldn't call these aren't the exact words I would use to name some of these parameters, but that's what CAP has chosen to use, so that's what we're teaching. Here they talked about the most experienced scanner will sit behind the pilot, and that's because the pilot isn't scanning. He's working hard on keeping that airplane going right down that track and flying accurately to put the scanners in a position to cover the terrain methodically. If the pilot is all over the place like this, then the scanners are going to be missing certain areas, and we won't get the same coverage that we're looking for. Okay, so that's the left rear, and then here's from the right rear, similar thing, diagonals, bigger field of view out here as you approach the scanning range. So you spend more time out there, less time in close. Ideally, we'd fly, if we could, a pilot, a observer, a left scanner, and a right scanner. We normally don't have that luxury here. We're personnel limited, and I would say the majority of the time we go out with a two-man crew. So of course the pilot will always be in the front left seat. The scanner or observer, depending on who's available, will be in the front right seat. So that takes some special maneuvering. We can't just go up one line, come down another line, go over like this, because we're only looking at one side of the airplane. So in fact, what we do is we go up one line, we come down the other line half mile away, and then we do a teardrop, a reversal, and go back up so we get coverage out the other side of the airplane, and then continue like that. So one side is just a transition from one line to another, and then the other one is a teardrop and back around again. And I think we'll talk about that a little bit later as well. Okay, I talked about repetition. I'm going to repeat this again because I think you're going to need to know it very soon. Scanning range, the maximum distance from a moving aircraft that a scanner can scan, and it's never greater than the search visibility. Search visibility is what I talked about, the distance in which an object on the ground, and CAP kind of uses a car as a fill-in for that, can be seen and recognized from a particular height. Now, if I was on a search for a missing person, then my search visibility would be, by definition, much smaller because it's much harder to see a person than it is a car. So search visibility is a function of both the object that you're looking for and the atmospheric conditions. That's something that Lieutenant Ng is going to talk about here. Yeah, 3 or 4 mile search visibility, that would be out in the open desert somewhere maybe. They talked about 100 miles an hour. The typical speed that we fly when we're doing visual search is 80 knots. So 80 knots would be about 92 miles an hour. Here we can see a practical application of what we're talking about. So you can see on the left-hand side, these are fists. It took me a while to figure out what these were. I figured out that the scanning range is going to be 30 degrees below the horizon. There's the horizon. 30 degrees below it is 3 fists. And so for whatever reason, they've decided that's what your scanning range would be. And again, your scanning range is always less than or equal to your search visibility. So I mentioned that atmospheric conditions and lighting are affecting scan effectiveness. That's pretty obvious, I guess, really. But what I want to show you here is they talk about objects, and they talk about the distance that you could expect to see those objects there. And you're going to see a common theme here pretty soon. A person in a life jacket in open water, a half mile. If you open that up to a raft now, a little bit bigger target, 3/4 of a mile. Person in open meadow, half mile. Person in a wooded area, half mile. So you notice all these things are half mile. And that's why we use that as kind of the going in spacing for search patterns. Vehicle in an open area, 2 miles or less. So some things to think about as far as lighting. Position of the sun is going to be important. So you don't want to set up a search pattern which has you looking at the sun on half of the runs there. And so it would be better to actually be pointing into the sun and away from the sun in the airplane. So make it a little tough on the pilot maybe, but that would allow the observers to be looking 90 degrees to the sun and to have a better view. We'll get a picture of some shadows here in a minute. The shadows can really be distracting and cause a lot longer to take to cover a certain area there. Of course, surface conditions. Window cleanliness is very important. So it's real important as a scanner to make sure the windows are clear. It's also important that we don't scratch or damage the plexiglass windows that we have in our airplanes. So if you need to clean a window, and you probably will, be sure to talk to your pilot about what to use. Some typical things, we have some white cream canopy cleaner you can use. Also, people use Pledge, the stuff you use for dusting your house. And that actually seems to work pretty well as well. But yeah, you want clean windows. And when you clean a window, it may not be apparent as you're cleaning it, but it's important to clean both surfaces, the inside and the outside. Binoculars, it's okay to carry binoculars, but we don't search with binoculars. We don't sit there with our eyes buried in binoculars looking for something. Number one, that'll get you sick. You'll probably throw up. And number two, the field of view of binoculars are so small that you won't be covering a very large amount of the area. If you want to carry binoculars, that's fine. And if you see something that's unusual and you want to put your glasses on it, your binoculars on it to see what it is, that's great, but don't plan on using them. Sunglasses help with the bright sun, but the way that sunglasses work is it cuts out part of the light. Anytime you cut out part of the light going to your eyeball, you're reducing your visual acuity. So I would say unless it is so bright that you really are uncomfortable, I would refrain from using sunglasses while you're searching. It may be a little bit hard on your eyes, but that's going to give you the best opportunity to spot something there. Fog, yeah, fog can certainly be a factor in more than one way. It can be a factor as far as the pilot being able to put the airplane where it needs to be, depending on what the visibility is, and being able to see a horizon and so forth. And then also that is going to limit how far out your scanning range will be, because your search visibility is going to be impacted by fog. And this next slide shows cloud shadows, and you see how when the Earth looks modeled like that, it's very difficult to pick up cues of things that are not natural, because all that modeling is not natural. So your eyeball just sees, you know, bright spots, dark spots, transitions, patterns, and that's exactly the kind of thing you're looking for when you're on a search there. What it may require is multiple passes, or you're decreasing the scanning range and making the passes between each run closer together to compensate for that. And of course, if you had a day like that, you'd want to put that in the remarks of your 104, your CAP Form 104, so that the AirOps branch director would be aware that there was something that impacted your efficacy as far as searching. That reminds me of Phoenix every now and then. We get these big old dust storms there when the monsoons come in. Haze, of course, can be another factor. A hazy day, you're just not going to be able to see as well. And the other problem that brings up too is on a hazy day, not only can you not see the target that you're looking for on the ground, but it's harder to see other aircraft. And same thing with fog, of course. And so that makes it more difficult for the mission pilot to clear his flight path and make sure that there isn't somebody else that's converging on your where you are. This guy had a bad day. That actually reminds me of a flight I had when I was in the Air Force. I was checking out to be an F-15 functional check flight pilot. And so I had to go through some formal training at Robins Air Force Base in Georgia. And my flight lead, as we're flying, took me way too close to some clouds. Got in there, got some hail, damaged the nose cone of the airplane. That whole nose opens up. When we open it up to access the radar, the whole inside had delaminated. So that was a multi-million-dollar error that he'd made. But anyway, the bottom line is hail is something we don't want to be around, of course. Okay, we already talked about binoculars. We use them briefly. Same thing with looking through a camera. You're not going to be looking through the viewfinder a long time. And CAP for aerial photography, we look through the optics. We don't look at the display on the back of the screen. And we talked about sunglasses affecting your visual acuity there. So now let's take a look at some things that we're actually looking for, some visual clues. And I'll just give you a chance to read through that slide there. But there's a common theme if you start looking through it. They talk about disturbed or discolored. They talk about breaks and disturbances. So the bottom line is you're looking for something that just doesn't seem right. As far as wreckage patterns, if you do come across an area where there's parts of an airplane there, if it's a big hole in the ground, it probably was a steep dive. A lot of times you'll get a whole line of wreckage there, and that's that creaming or smear, where basically the airplane flew into the earth in controlled flight and level ground. Little pieces everywhere. That's probably in-flight breakup. This hedge trimming, it's interesting that so many mishap aircraft just barely miss the top of a ridge. And so as a result, as it's just passing that ridge or near the top of the ridge, you can get this hedge trimming. So here's some actual aerial photographs. And you can see right here, you really can't see much of anything. It looks pretty much the same as the rest of the area. But as you get in closer, now there's something that just doesn't seem right there. You're not really sure what it is. Definitely doesn't look like an airplane, but it doesn't look like it belongs there either. Another example, green. Everywhere it's lush green. It looks like a forest that's used for logging. So it's fairly uniform. But you can see this area of discoloration. And if we zoom in a little bit closer, you can see it even better there. So those are the kind of things that you're looking for. Another example, more discoloration. What's that discoloration? Probably a fire that developed after landing. And here you can see it. You see it much better. So it's quite seldom where you're going to see something like this, where actually you have a airplane that's intact. This airplane took off from an airport and for whatever reason wasn't able to climb, maybe a problem with engine power or weight exceeding the gross weight of the aircraft, stalled and then went right into the trees. There's an airplane that's broken up. You can see parts of it, the tail, part of the fuselage, one of the wings over here. And it looks like maybe the other wing over there. So in this case, you see there's debris everywhere. The spots here, all over the place is debris, which would indicate in-flight breakup. As you get in closer, you can see again pieces everywhere. Now, if you're lucky, you'll be looking for a guy that ends up in a cornfield, and it's very easy to spot something like that. And you know, if somebody's doing a engine out and landing where the engine has failed, cornfield might be a pretty suitable place to land the aircraft. So that's another reason that you might see airplanes in a cornfield as opposed to some other kind of terrain. This shows you that many times, just like we saw on that in one of the previous pictures, an airplane will take off, and before it even gets more than a couple miles away from the airport, it'll end up impacting the ground. So if there's some issue with the flight controls, with wind shear, weight and balance, that's one of the first things we want to look at is the airport. If we have no other clues at all, is take a look at the airport of departure. R-22 is a small two-place helicopter. And I got several pictures here of a crash site. Jackhead has to do with pumping oil or gas, some kind of a well in the desert here. And this unfortunate R-22 ended up right next to that jackhead. There's the jackhead there, and there's the wreckage from the helicopter. Here's an example of a power line, and there's a power pole, and actually the top of the power pole got clipped as the airplane went in. But surprisingly, even though the top of the pole got clipped, the wires stayed intact and just basically became disconnected from that particular pole. And there's an example. There's a picture right there. You can see where the insulators were on the power lines and the severed pole, and the lines are still intact. And I guess that's that same yeah, it is, because there's the jackhead there, the oil well. So that's the same R-22. Basically flew right into the jackhead. Anybody see where the aircraft might be in this picture?
Right in the middle.
Yeah, right in the middle.
Right there?
Yes.
Okay, let's take a look and see. Yeah, there it is. It's intact. See this large boulder here? That would be that boulder right there. So yeah, good eyes, guys. I mentioned earlier that it's quite common for aircraft to crash right near the point of departure. And here's another picture that bears that out. You can see the runway here. I'm not sure what direction he took off, but right next to the runway is where he impacted. Now, of course, here with all this population, that would have been discovered right away normally. But it's interesting that it happened so close to the airport. close-up of that same accident. Well, we don't have a whole lot of snow in Hawaii most of the time, unless you get up on the top of Mauna Kea. And then, in fact, there is snow from time to time. So it's possible to be searching an area with snow. This picture, I'm having trouble myself finding the wreckage. Anybody see it? I don't.
I think it's where that middle tree is in the center to the right of it, to your 1 o'clock.
About here somewhere?
It looks like it's
right
the arrow.
there.
The bushes are like an arrowhead. You see the black thing sticking up? Yep, right there.
Yeah, okay.
Like for the first picture, I wouldn't have noticed the plane if there wasn't that the red circle on it, but this one, that's hard.
This one is definitely hard, yeah. And that's the point. If it's snowed and you got snow covering the wreckage, that's going to be a tough one.
Also, if you look at it, there's a straight line from that tree going up to the bushes where the airplane landed.
This line
rested.
Here.
Yeah. You don't have lines like that in nature.
Yeah, that's a good point. You're looking for something that's unnatural, and sure enough, that is unnatural there, isn't it?
Wow.
Let's see. This one is this the same one? No, it's a different one, isn't it? Yeah. Well, finally, something easy. Now here's a place with just some tumbleweeds out there that you could expect to see things for a long ways away. So you might have a search range of 2 or 3 miles.
Where's the airplane?
Where's the airplane? You must have your sunglasses on.
Binoculars.
Okay, so the whole gist of this whole thing is looking for unnatural occurrences. Something just doesn't seem right there. Let's shift gears a little bit. Instead of talking about searching for airplanes, how about missing people? Well, the first thing you need to realize is they are very difficult to spot. And if they're not actively trying to signal you, it's going to be very tough. So you need to really bring in that search range. You need to be aware of what color clothing they had, both their external clothing and then some underclothing. If they had like a jacket and then a shirt on underneath, you'd want to know what those colors are, and that will help you focus on detecting those colors. And it's interesting that lost children and people that have mental issues, a lot of times will actually hide from searchers. And also children, for some reason, like to travel uphill. So if they're lost, they don't know what to do, they go uphill there. We did a SARX a while back and had somebody at La Perouse. And even though we knew he was there, we had a very difficult time spotting him from 1,000 feet. Okay, so here's some examples of spotting people. And again, you can see that they are very insignificant in size when compared to some of the other objects that are out there. And so your eyeball is naturally going to focus on some of these bigger things. And the chance of seeing this, if he's not in motion, not signaling you, is going to be tough. So that's at 1,000 feet. Now we drop down to 500 feet. And even at 500 feet, it's still challenging to pick out the person there. You know, having this red circle there, we're not going to have those for real. Here's a yellow shirt. I think we can pick up just maybe a little bit of yellow there, depending on the quality of the transmission here, which screen you're looking at. The blue stands out pretty well. I think of all the colors I've seen so far, the blue would be the one that I'd most likely be able to see under this particular lighting conditions.
I have a question, Colonel Benedict.
Yeah, go ahead.
Since we wear green bags mostly, or dark shirts and gray pants, what's that do for us if we were to go down?
It makes us hard.
Should we be having maybe orange vests in as well in our personal carry-on survival stuff?
Yeah, that would be useful. If you have like a space blanket that maybe is silver on one side and orange on the other side, would be a good thing to have. You could wrap that around yourself even as you're moving, if you're walking somewhere. Yeah, unfortunately, our flight suits do blend in with the terrain. Years and years ago, CAP used to wear orange flight suits, international orange, and that was the same color that the air defense fighters, the F-104, F-106 guys and the F-102 guys would wear. But for whatever reason, that has gone away now, and everybody is oriented more towards combat. Yeah, that's a good question, Chas. Yeah, and we'll talk about fatigue here for a second, and I'll tell you to cover a CAP quarter grid, and we'll be talking about the grid sizes tomorrow. But to cover a CAP quarter grid, which is 7.5 miles north-south and maybe 6.5 miles east-west, to cover that area takes about an hour and a half. So that's a long time to be in that area, and that's why it's important to reduce fatigue and manage fatigue so that we do a good credible job. You know, our object isn't just to sign off a bunch of searches that have been done and not actually cover the area. Our objective is to cover that area. So some things to fight fatigue. They talk about changing seats if you're in a bigger airplane. Get comfortable. Take breaks. Normally, if we're doing a grid aligned search, in other words, we have a square over the ground that we're going to cover, what we'll do is fly through the grid, and then when we hit the other edge of the grid, we'll kind of relax as the pilot turns the airplane around and re-enters the grid. So that's an opportunity there to do that. Talked about binoculars, staying hydrated. Chaz talked about that. Some snacks, keep your blood sugar up. And bottom line here, I think it's important. Don't be a hero. Speak up. If you're just tired and you need a break, then we'll climb up to a safe altitude. Probably the rest of us all need a break too. We just didn't want to fess up. So as part of a crew member, part of a crew, it's a joint effort, and everybody needs to be working at it there. Okay, we're getting to be just about done with this module. Let me talk about clock positions. In order to have one person in the airplane look where you're looking, or have you look where they're looking, we use clock position. So right in front of the airplane is 12 o'clock, like a regular clock. Out the right wing would be 3 o'clock. Behind you would be 6 o'clock. Out the left wing would be 9 o'clock, and the appropriate positions there. So if there was something over here that I wanted to bring the pilot's eyes to, I would say check right 130. And you always want to preface it with right or left, because in the heat of the battle, I might get mixed up and I might think that's 10:30. And I'll tell you, I've done it many times, and I do this for a profession. But what I don't mix up, I never mix up my right and my left. I always know this is right. I always know this is left. So so you would look at right 130, and then you're going to talk about whether it's above the horizon, it'd be high, on the horizon, it'd be level, or below the horizon would be low. So that's an example. So let's see, if I wanted if I saw something and I wanted the pilot to start flying in this direction, what would I tell the pilot? Because I don't have a compass in the back. I don't know which way is north or south or anything else.
Left 8 o'clock.
Yeah, that's right. Come left 8 o'clock. That's right. Now, if I said come right to 8 o'clock, where would the pilot turn to? If I said come right to 8 o'clock, he would go to this 4 o'clock position. And the reason that he would do that is because I got mixed up on my 8 and 4s, but I said right. And so this same position, 4 is in the same relative position as 8 is on this side. So again, the direction, like left or right, the clock position, and then the elevation there. You can also say something like come hard left. So if you see something on the ground and you can't take your eyes off of it because you might lose sight of it, the term we use for that is called padlocked. I'm padlocked on that sighting. And so you'll tell the pilot come hard left, or ease off your turn, or roll out, or drop your left wing. As the scanner, what we want to do is talk the pilot's eye onto the point of interest. And then once the pilot is on it and sees it, then he can maneuver the airplane around to put the scanners in a position to see it much better. So the idea is to be directive. Tell the pilot what he needs to do. And then the other thing, if you're looking at landmarks, then you talk his eyes onto something. You start with a large, obvious landmark, like take a look at that river at left 9 o'clock, and then follow it down to the second island, and then come in about 10 degrees. That's where it is. Something like that is what you might say. So start with large, something big, and then refine it and you talk somebody's eyes into it like that. And it might be the other way around. It could be that even though the pilot's job is to fly the airplane, he might spot something and he wants you to check it out. And so in that case, the pilot will talk your eyes onto whatever that finding might be so you can check it out. Okay, so yeah, I'll let you just read through that whole dialogue there about how the crew would work together in order to pick up a target. So you can see there's a lot of direction that's going on.
Would you comment on the last one on that previous slide? Target is at 3 o'clock, half mile off the wingtip. Drop the wing and you should be able to see it. Would it be beneficial to use that as 3 o'clock right or left as appropriate?
Yeah, it would be better to say, exactly, good point. The target is at right 3 o'clock. Exactly. Yeah, that's a good observation, Chas. Okay, so we've already mentioned this a couple of times. We're not looking for a 747 out there. We're looking for little pieces of things that aren't right. Anytime you do have a possible sighting, you want to write it down in your log. And particularly if you get a sighting, but then you can't find it. And that happens. It's really frustrating. You spot something, and then you don't see it anymore. And that's just because of the angle that you're approaching it, probably. Trees and stuff are blocking it. And you go back and you try to find it, and you look and you look and you look, and you can't find it. That's really frustrating because it might have been what you're looking for. But that happens. What we want to do in a case like that, though, is mark the position. And Daryl should be talking about that. And report it in our debrief so that it can be checked out on another day. And particularly if several people see something in one particular area, well, then the incident commander or the Air Ops branch director can dedicate a sortie for that particular thing to check out that area. We're going to talk about search patterns later on, so I'm really not going to talk about that now. This is a great picture. I wonder what that goat is doing up here.
Naval Academy.
Talking about on a steep slope, and they use 500. Typically, if you're doing a contour search, you'll do 500-foot increments. But if it's very rough terrain and it's easy to miss things, then you might lower that to 250 foot. So you'd fly at a certain constant altitude, and then you turn around, you drop actually first 250 feet, turn around, come back the other way. Scanning a plateau, if you see if there's a plateau somewhere that's part of a slope, you don't want to be level with the plateau because you can't really see into it because of the foliage right here will block your view. So you need to be in a position where you're looking down into the plateau. That's what this is showing here, that we're looking into it there. And so that may require a deviation from your very rigid search plan, but you have to be flexible when you're out there. In foliage, the foliage can cover up whatever's below it easily. In general, you're better off looking straight down into foliage than you are looking at an angle in foliage. And here's a good thing. Don't hesitate to ask the mission pilot to refly a certain area. If there's an area where you just couldn't see, or if there's an area where for some reason, whatever, you ended up daydreaming, and you're just kind of going through the motions, don't be bashful about having the mission pilot go back and do that again. That's part of our job there. We talk about this Steve Fawcett search in Nevada and California wing when he disappeared a few years ago. I ended up flying into a sheer cliff, and they really couldn't see anything from air at all. It ended up being found by hunters, I think a year later. Here's what I'm talking about, looking down instead of looking diagonally. This is what to do after a target is detected. One of the important things is to capture the coordinates, and we will cover that. Do you cover that, Daryl, on yours? How to use the GPS to get the coordinates?
Yes, I touch on it a little bit, but it's really just one slide.
Okay, I can. I'll fill in on that as well then if we need to. Okay, finally, we're at the end of scanning techniques modules. Anybody have any questions? So what are the salient points that we talked about? What are the important takeaways? Anybody? Are we looking for whole airplanes, or are we looking for signs that aren't natural and small pieces?
Signs that are not natural and small pieces.
Exactly. That's one of the things. Do sunglasses help scanning?
No.
Not really, no.
No, they're going to decrease your visual acuity. And when you're scanning, is it better to scan in constant motion where you're sweeping your eyes, or do you want to fixate?
Fixate.